All right. So now this lecture series is going to be about teaching electricity using the most basic concept, voltage, current, etc. to so that we can develop our own small scale projects using solar power. So first we'll start with what.
First, we'll start with introducing ourselves. Like, you can give your introduction.
Okay, so I am Rohel Butwala. I'm doing a master's in electrical power in Germany right now, and he's also doing master's as well in mechanics.
Hi guys, let me introduce myself. So, hi guys, my name is Sumit. I'm from India and currently I'm studying Masters in Production Systems Engineering at Erwete Aachen. So, and we are here for our first lecture, which is on basically on electricity and the basics about electrical engineering. So I guess like Rohel will help me to understand all the sorts of basic fundamentals in electrical engineering. So shall we get started?
Yes, let us
Okay.
begin. So now electricity is affected by at the most basic level by charges. It can either be positive charge or negative charge.
But first of all, when thinking about electricity,
Yes.
the question comes to my mind is like exactly what is electricity? This is what I feel like coming from a mechanical background, that this is something that I cannot see or imagine like how this phenomenon works in real world.
So consider this, that our world is like made up of different layers of reality. So electric field is also another layer of our reality. Like अपना electromagnetic waves होता है, electric field होता है, जो हम लोग interactions करते हैं, all of that is dependent upon the electric field. For example, sound, the moment of sound, the force that pushes one atom against another so that the sound is propagating. That force that is pushing and that the force that is being received, the interaction requires charges, and it is the repulsion between two electrons that causes atoms to bounce against each other. So electric field is pretty layered into who we are as there is nothing possible without the electric field in our universe. So now what affects electric fields? It is positive charges and negative charges. So what are positives and negative? It is nothing. There is no reason why we cannot call the other one negative and why we cannot call the other one positive. There is technically no difference. There is just two different kinds of things.
You mean to say like this stuff is somewhat we have to imagine it ourselves, like electricity. We cannot see the atoms physically.
Yes.
We cannot see the charges physically.
Yes.
It is the thing that has been tested through experiments, and from the results it's been like decided that the positive charges they behave like this, the negative charges they behave like this. It's based on experiments, or like it's certain that there are things that behave like this and we call it the negative charges.
We observed that
charges.
things behave like this and we decided to give it a name कि अगर ऐसा बिहेव कर रहा है तो पॉजिटिव चार्ज, ऐसा बिहेव कर रहा है तो नेगेटिव चार्ज.
Okay.
So then over time, as when it came to the point we were able to zoom into the atom and see what is going on, that is when we figured out that this behavior of negative charges is because of electrons and this behavior of positive charge is because of protons.
Okay.
So that came afterwards. So electric field. So now consider lightning. Before lightning strikes, there are people who perceive their hair being raised into the air because there are charges in the cloud that is causing the air and that is causing the hair to have separation of charges and act slightly attracted towards the cloud. तो उसके वजह से मालूम पड़ता है कि हाँ भैया lightning का possibility है यहाँ पे. So what it means that electric field affects our layer of reality already just by giving this example. So now we try to figure out how to understand it. What affects the electric field? It is the positive charge, positive, and the negative charge.
Okay.
So we assume that the electric field is being emitted by positive charges. ठीक है? And for negative charge, we assume that electric field is being dumped into this. ठीक है? We have just given it like this is the convention कि हम लोग को imagine करना है कि ये कैसे काम कर रहा है, तो हम लोग उसको ऐसा assume कर रहे हैं कि हाँ भाई ऐसा काम कर रहा है.
तो मतलब ऐसा है कि जो सपोज एक जो प्रोटॉन है, लाइक we have given that it is like I didn't understand what exactly it's like, just let me know in layman's terms.
And electron पता तेरे को क्या है?
इलेक्ट्रॉन मतलब मेरा जो कंसेप्ट है जो मैं स्कूल में पढ़ा था, मतलब इलेक्ट्रॉन होता है जो एटम में होता है और उसको नेगेटिव चार्ज होता है, पर ये क्यों होता है क्या होता है इसके बारे में कुछ पता नहीं.
तो वो प्रॉपर्टी ही पकड़ लो उसका. तो it like it goes into even deeper level if you want to go, it goes into quantum mechanics after this. So it is not necessary right now. For positive charges we usually use protons. Like for example electron negative charge बोल रहा हूँ, it is not just electrons that have a negative charge. There is another particle called muon. There is another called tau I think. तो
इसमें ऐसा कुछ है क्या कि जो पॉजिटिव चार्ज रहता है वो हायर पोटेंशियल पे रहता है, या निगेटिव चार्ज रहता है वो लोअर पोटेंशियल पे रहता है, इसलिए द फ्लो ऑफ चार्ज ऐसा होता है हायर पोटेंशियल टू लोअर पोटेंशियल. जैसे हम पानी के इसमें बात करते हैं, अगर पानी एक सर्टन हाइट पे रखेगा सो इट विल बी एट हायर पोटेंशियल, और उसको अगर लोअर पोटेंशियल पे आना है like it has to like potential energy will get converted into kinetic energy, and then this energy which is given out it will bring it to lower potential. तो ऐसा कुछ चार्जेस के इसमें होता है क्या?
हाँ ना, तो लाइक ऐसा पकड़ ले कि ये यहाँ एक टावर यहाँ पे, ठीक है, टावर के इधर सब पॉजिटिव चार्जेस है, पॉजिटिव 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 पॉजिटिव, ठीक है. Now, so each positive charge is repelling the other positive charge. It does not depend where we make a hole, but if we make a hole, some positive charge will find a way to escape. Like assume that this is contained. So each positive charge will try to escape through here because it is possible to escape through here.
Okay.
ठीक है. तो अगर positive यहाँ से अभी escape कर रहा है, which means it is moving. So if a positive charge is moving over here in this direction, it means there is a current. This is a current.
So the flow of proton or flow of positive charge, it basically leads to the current.
Flow of charges leads to current.
Okay. So अभी ये charge flow हो रहा है, इसका मतलब there is current.
हाँ.
Okay.
तो वो पहले पोटेंशियल डिफरेंस था, पहले पोटेंशियल था यहाँ पे, लाइक वोल्टेज बना हुआ था, ऐसा पॉजिटिव चार्ज यहाँ पे है. It means there is a voltage over here.
Okay.
And now it gave it a path for the charges to flow. तो इसलिए वो flow हो रहा है, इसका मतलब करंट भी जा रहा है. तो because of this potential difference, because of this potential over here and another potential over here, ground पकड़ ले यहाँ पे, like ground over here. So there is because of the potential difference between this and this.
जो ground होता है, ground पकड़ा हमने क्योंकि ground is assumed to be at zero potential.
Yes.
Okay.
तो इसीलिए like we see the charges flow from higher potential to low potential, which is ground in this case.
Okay, तो अभी मेरे को ये सवाल उठता है यहाँ पे, like I have a question, like whenever like if there is some electrical gadget, so for the safety of human beings, like all the appliances they are usually ground. So there goes a wire which is connected to the earth.
That is a different kind of ground that you're talking about. So one ground is the electrical ground, कि वो सर्किट को काम करने के लिए कोई कॉमन पॉइंट चाहिए होता है ना, कि इसके हिसाब से इसका पोटेंशियल डिफरेंस 5 वोल्ट है 9 वोल्ट है, तो उसको एक ग्राउंड होता है. दूसरा ग्राउंड होता है जो जमीन में डालते हैं, कि अगर आप एक मेटल केसिंग हुआ किसी ऑब्जेक्ट का और उसके ऊपर गलती से एक लाइव वायर टच हो गया वो मेटल केसिंग के ऊपर, तो अगर तू मेटल केसिंग को टच करेगा तो फिर शॉक लगेगा तेरे को. तो टू प्रिवेंट दैट व्हाट यू डू इज, तू एक वायर लेता है और मेटल केसिंग को डाल देता है, और वो वायर सीधा ग्राउंड पे जाता है थ्रू अ ट्रिपर में भी, ठीक है. सो व्हेन अ लाइव वायर टचेस दिस मेटल केसिंग, वो बिकॉज ऑफ दैट ग्राउंडिंग वायर इट विल बी शॉर्ट सर्किटेड टुवर्ड्स द ग्राउंड, क्योंकि कुछ भी पास में बचा नहीं है, खाली वो एक ट्रिपर बचा है. तो जैसे वो करंट जाएगा ग्राउंड वायर के थ्रू अपने धरती की तरफ, वो ट्रिपर को मालूम पड़ेगा कि हाँ भाई कि कोई तो एक अप्लायंस है जिसको फॉल्ट है, तो वो ट्रिप हो जाएगा और वो ऑन कर लेगा वो अपना ट्रिप को. and it will indicate कि yes, there is a shorting problem somewhere. Metal casing coming.
So guys, here the live wire means a wire through which the current is flowing. So that we need to take
Live wire is one from which current can flow.
Okay.
The possibility to flow. तो अभी फॉर एग्जांपल ओवर हियर ग्राउंड जब बात की है तो ग्राउंड जो मैंने ड्रॉ किया, ठीक है, ग्राउंड जो ड्रॉ किया मैंने, इट कैन ऑल्सो बी दिस नेगेटिव हुई है, नेगेटिव पोटेंशियल यहाँ पे हुआ, पॉजिटिव पोटेंशियल यहाँ पे हुआ, तो पोटेंशियल डिफरेंस टोटल बन जाएगा V माइनस V इक्वल टू 2V. तो विद रिस्पेक्ट टू ग्राउंड इट इज जस्ट V. बट अगर नेगेटिव पोटेंशियल के रिस्पेक्ट टू हम लोग देख रहे हैं कि कितना चार्जेस फ्लो हो रहा है एक्सेट्रा, तो इट विल बी ट्वाइस बिकॉज माइनस बिकम प्लस.
Okay.
So now we have positive charges and we have negative charges. ठीक है, तो अभी पॉजिटिव चार्ज हम बोलते हैं कि हाँ इलेक्ट्रिक फील्ड उससे बाहर आ रहा है, पॉजिटिव इलेक्ट्रिक फील्ड बाहर आ रहा है ऐसा, ठीक है. एंड अगर नेगेटिव हुआ तो वी अज्यूम कि इलेक्ट्रिक फील्ड इज गोइंग इनसाइड इट.
Okay.
जस्ट टू एज अ कन्वेंशन समझने के लिए कि इलेक्ट्रिक फील्ड कैसे काम कर रहा है. तो नाउ voltage, so voltage is the collection of positive charges over here. Collection of positive charges emits an electric field, and therefore it can cause charges to flow. Negative will flow towards it, positive will flow away from it.
Okay, like abhi, like I have a confusion over here. Like, is it simple to understand? Because usually I have the confusion like the flow of negative charge constitutes the flow of electricity. Like, how does this work out?
So it is the flow of positive charges that constitutes the flow of electricity. लेकिन in most cases it is the electron which is flowing. Like अगर यहाँ पे बैटरी डालते हैं, ठीक है, रेजिस्टेंस और यहाँ पर, और ये पॉजिटिव बोलते हैं नेगेटिव बोलते हैं, तो बोलते हैं कि करंट ऐसे जा रहा है. However, the electrons are flowing like this. It is going from the negative point because it is a negative potential, which means it has more electrons, you can say, as compared to the positive potential.
Okay.
तो ये इलेक्ट्रॉन अभी फिर ये अट्रैक्ट होके यहाँ पर जा रहा है, इधर पहुँचेगा वो.
मतलब बेसिकली जो नेगेटिव चार्ज है वो हायर पोटेंशियल पे जा रहा है.
Yes.
यहाँ पे.
Yes.
पर वो क्यों जा रहा है फिर?
क्योंकि it is being attracted toward it. Now, for example, consider like this.
Is it the case that the positive charge is pulling the electron, or the electron at the negative level is repelled by the other electron?
Both.
That's why it's forced into the positive charge. Both. Okay. But which effect is greater that constitutes to this?
Both of them are the same thing.
So जो सेल और बैटरी बेसिकली जो रहता है वो सिर्फ ये पोटेंशियल डिफरेंस क्रिएट करता है.
Yes. That is when you have a battery. जैसे बैटरी का कुछ सिंबल बनाते हैं ना, तो इसका जो एनर्जी होता है, देयर इज स्टिल एनर्जी इन द फील्ड अराउंड इट. इलेक्ट्रिक फील्ड ऐसे जा रहा है उसके हवा में, वायर कनेक्ट किया है तो भी चलेगा, नहीं किया तो भी चलेगा. देयर इज एन इलेक्ट्रिक फील्ड फ्रॉम द पॉजिटिव टू द नेगेटिव. ऐसा है, होता है इलेक्ट्रिक फील्ड हमेशा.
So is this the case that if a battery is kept for long without being connected with the help of wire from positive charge to negative charge, would this happen that the battery might get discharged due to this?
And no, because air has a very high resistance. That is why the electric field is possible for it to be there. If it had low resistance, it means electrons were able to move freely. And if electrons are able to move freely, they can respond to any electric field. And if the electron can respond to electric field, that means कि वो इलेक्ट्रिक फील्ड का इम्पैक्ट कम हो जाएगा, मतलब दिखेगा नहीं बराबर से वो, क्योंकि वो इलेक्ट्रॉन रिस्पॉन्ड कर रहा है उसको वापस.
Okay. So like when we connect a wire at both the terminals, what happens is that the electrons which are at random motion, it becomes organized.
Yes.
So this constitutes the flow of current.
Yes.
Okay.
So that is voltage current. Now, in the terms of pani analogy, if we use pani analogy, how do you figure out what is electricity? So let's make a dam. So a dam.
So guys, what we are doing here is that we are taking the analogy of water in comparison with electricity, right?
With yes.
Or with current.
Yes, yeah, electricity. Water flow and electricity.
Water flow and electricity. So electricity, which is like very difficult to imagine as it happens in between like the closed walls of wires and batteries, which is very difficult for the students who are studying other things rather than electrical engineering. So what we are doing is we are taking the physical phenomena such as water and the movement or the properties of water, how it acts to certain conditions. We are using those properties to make you understand how the electricity functions.
So now consider this dam over here. Alright, dam here. So dam has the potential for water flow, so which is equivalent to a battery. So battery बन गया. Now over here at the dam, if you ठीक है, तो अभी ये डैम का पाइप कनेक्टेड है यहाँ पे. This pipe is connected to for example, let's say एक water wheel. ठीक है, यहाँ से जब पानी फ्लो होता है then it rotates and energy is extracted from. No, there is currently no water flowing, so the switch is off. You can call it switches off. Energy.
So do you mind if I explain the mechanical related properties, then you can explain the electrical related properties?
In a bit.
Okay.
So now we have this energy extraction method over here using this wind turbine. We can let's call it a resistance. ये जो heat यहाँ से निकलेगा वो energy extract करने का try कर रहे हैं हम लोग.
Okay.
So now this resistance represents the extraction of the energy. Now
so the pipe represents wire then.
Yes. So we attach a battery over here. We have a switch.
What you can say is also a mechanical switch, which might allow to either block the flow of water or to open the gates.
So we have a switch, and then we have a resistance to extract the energy. We will be extracting from here, and this you can consider it as the ground over here. This also over here is the same ground. You instead of drawing a line between this, I'm just representing it as the ground. Now,
so what we can represent ground as in?
As the common point on the lowest level of the circuit, the sea level of
the ground level.
The ground level of the circuit.
Okay.
Like this is the ground level of this environment. This dam's ground level is over here where the pipe is.
So maybe you can show a pipe which comes from top, so that it will also like give this energy to the water to flow.
Yeah, over here it is going to be over here. Over here, this is where the water will be entered, and this over here is a valve. That valve can be open or closed. So this acts as a switch. Yeah. So now if we open the valve, that means we are technically like closing the switch, and we are causing the water to flow over here. So now the water will flow, and once it reaches over here, it will start turning this wheel, and because this wheel is turning, the energy is extracted from it, causing some of the energy to be lost from this place.
Okay, so यहाँ पे क्या हो रहा है, मतलब जो water है वो आ रहा है एक higher velocity के साथ आ रहा है बोलो, क्योंकि like it's coming from a higher potential. So एक अगर वो higher velocity के साथ आ रहा है तो पर बीच में उसमें टर्बाइन ने उसको रोक दिया वाटर को. सो अभी क्या हो रहा है कि वाटर का स्पीड जो है वो कम हो गया क्योंकि देयर वाज अ रेजिस्टेंस, राइट. तो अभी वाटर टर्बाइन के आगे जो फ्लो होगा वो थोड़ा कम वेलोसिटी के साथ होगा. So how can we relate this terminology in case of current?
तो अभी यहाँ पे करंट में देखिए, यहाँ पे स्विच जैसे हम लोग क्लोज किए है, द करंट बिगन फ्लोइंग ओवर हियर आई. तो इन टर्म्स ऑफ V इक्वल टू IR, दिस इक्वेशन साइड करके यहाँ पर एक करंट फ्लो होगा यहाँ पे. That current,
Oh, this is like something very technical coming up. What is V, what is I, and what is R?
V is the voltage. जो voltage हम लोग बात कर रहे थे, देख ले. What is the potential for flow? Potential for flow is the voltage.
Okay.
The resistance is what is resisting the flow to extract energy from it, or whatever the reason. Resistance is resisting the flow.
Extract energy for it, or the energy is lost due to some reasons.
And current is the flow of electrons.
Okay, basically means the flow of water.
Yes.
Okay.
So now V equal to IR is the equation. डालते हैं हम लोग. Now, when the switch is closed, the current will flow over here as a wave. So it will be a very quick wave, but it will flow and it will become a stable point where V equal to IR will become the reality of the circuit. So the current, however, the difference over here between the current and the flow of water is that the current does not slow down after it when it encounters this resistance over here. To be precise, it does not slow down over here after it has left the resistance. Inside the resistance, it bounces with the crystal structure, the atoms inside the resistor itself. But the magnetic field around the wires, it speeds up the electrons once again, causing it to increase, like have the standard speed that is there for the entire circuit. The number of electrons cannot.
Will the value drop down
Let me repeat.
resistance?
No, let me say again. Yes, at the resistance, the electrons, after colliding with the atom, they slow down a bit. But the magnetic field, so there is a magnetic field around. There is a magnetic field around the wire, which is given by the right hand thumb rule. Okay, just you don't need to worry about it right now too much. It is a component of electric field. Okay? Just like electric field exists, we also have a magnetic field. We have magnets. This magnetic field.
So these two things, electric field and magnetic field, they go hand in hand.
Yes.
Okay.
So now this magnetic field ensures that the speed of the water, the speed of the electrons, gets back to the average value, which is represented by the magnetic field. Okay. So that will be the difference over here.